So we will pick this up by filling in the rest of this. So where were we? Solubility of which? Polar. All right. If you were gone, anyone gone yesterday? They'll catch you up pretty quick. You're pretty bright. So both of them, hopefully fix you. It's not hard. So here we go. The solubility of polar things, we want water/polar. Is that correct? We should have. Oh, heavens, Thomas. Now, based on your table, did polar things conduct? Do you remember? Look at your data table. Do the polar things conduct electricity? No. Greer says no. I agree. Post agrees. Everyone hopefully agrees. They have none, actually. Just put none. Were polar bonds brittle or malleable? Okay, they're liquids, but let's think about water. We know water's polar. When water's a solid, it's ice. When you hit ice with a hammer, does it bend or does it shatter? Shatters, so that means these things are brittle. Now, they are liquid, usually at room temperature, but if we ask brittle or malleable, we mean when they are a solid, are they brittle or malleable? All right, then the melting point and boiling point for these, they are the ones that are the medium. Good so far? Silence means yes. All right, solubility of nonpolar. We're not going to write water in polar because it wasn't. We're going to write hexane/nonpolar. So it will dissolve in hexane, or they will dissolve in other nonpolar liquids. All right, conductivity. Look in your table and tell your lab partner if they conduct. Do you agree, Reagan? So their conductivity, according to the front smart kids, is none. Who agrees? Well, obviously I do, or I wouldn't have written it on the board. All right, malleable, when they are solid, are they malleable or brittle? They're brittle. Look at naphthalene. It should have been written that it was brittle. Sometimes the sentences that come out of me, I don't even know how they start, but whatever. Melting point and boiling point, these are the ones that we consider to be low. Then, our metallic bond. Did any of the metals dissolve in anything? No, metals don't dissolve, so put none. Do the metals conduct? Yes. Now, I'm going to put yes. That's stupid. Yes, but I want to also have you add in pure form. That will eliminate any confusion at all, because it might say, does it dissolve in solution, or will it conduct in solution? You're like, hey, metals conduct, so yes. But the answer is no, because metals don't form solutions, so they only conduct in pure form. Is that all right? Malleability, metals are malleable. And then they are considered to have a high melting and boiling point. All right. Everyone have that? This is a very important tool for you to have for your exam. Go ahead. Never mind, not a question. So let's go ahead and I'll practice how, yeah. So they're water/polar. Only in solution do they conduct. Malleability is brittle. And melting and boiling point is high.
Thank you.
You're welcome. All right, so what we do with this chart now is we apply how to find the bond type, the math we did, and then we apply these principles together. So for practice, you might get something like this. All right, so you might have a structure like this, and then answer these somewhere not on your periodic table. So it might say, does it conduct? Is it brittle? Dissolve in water. 4. Dissolve in hexane. Why don't you see if you can answer those 4 questions just given this structure of NO2. Take a minute and try that out. So the first step to solve one of these problems is to figure out that this is what type of bond? Is it nonpolar? I don't have it memorized, so nonpolar. I thought it would be polar, but that's fine. All right, will nonpolar things conduct? No. Are they brittle? Yes. Do they dissolve in water? Nonpolar, they don't. And then they do dissolve in hexane. Who had that 4 for 4? Okay. Hello, Zimmerman. Oh, he looked away. I feel like a nerd now. Thought I had cool friends, and then they went to a party without me. Easy enough. Okay. So, I don't know. For practice now, shut this table completely, and you're going to do another table just like it. It's okay. It's on page 16. It's exactly like it, but use this. It'll take like 2 minutes. Use this now to answer so that you are very comfortable. You don't have to. Take a nap right now. Don't even try. Okay, good. But the rest of you, practice so you can get good, because this is a big chunk of your exam. All right, so what the kids have been doing right now is taking the guru quizzes. They're called bonded matching and bond properties. So if you would log into Guru and take those 2 quizzes, that's what we're doing. Schemata. So let's open this up. Needed more dryer sheet. It is very electrostatic. All right, this giant thing that you're looking at is called the naming schemata. We will get some for the rest of you. So the first thing you should do is fold it so that the front says common polyatomic ions. That's the way we're going to work. That's the front page. All right. What you see on the screen is the middle we'll talk about. But before we get here, let's talk about this side, the common polyatomic ion side. And I don't have it cut into this presentation. I'm going to just borrow Greer's here and we'll talk. So this giant piece of paper is much like your periodic table in the fact that you get to use it on every test. And you'll need to from now on. Now there's a lot of words, and this seems overwhelming at first, but in the long run it's super simple and extremely helpful. So the first page, common polyatomic ions. What it is, an ion is something that's charged. Poly means more than one, and atomic means atom. So it's a group of atoms that are together that have an overall charge. And they are involved in ionic bonds. So if we ever have a polyatomic ion name or formula we need, we'll find it on that front page. It is organized in that the first left column, everything in there has a charge of -1. The second column over, those are -2 charged polyatomic ions. The third column is 3. But will you all take a second and put a box around the one that is bold that says ammonium? Ammonium, box that whole thing. That is the only polyatomic ion we have that is positively charged. All the rest of them in this class will be a negative charge. Now, why that's important is polyatomic ions almost all the time are at the end of molecules, but if they are that one of NH4, then they're at the start. All right, now turn to the middle just real quick. There are some very important parts to this in the middle that you will use a lot. So first thing first, this box right here, if you'll all look, when I was in high school, I had to memorize the name and formula of acids. I don't make you memorize them. If you need the name or formula of an acid, it's located in that box. Good enough? Okay, now look up here for a second where the giant red arrow's pointing. These are prefixes. Prefixes are things that go before words. And you've heard of the prefix di whenever you've said the word carbon dioxide. What did the di mean? 2. It means CO2. All right, carbon monoxide then. Any guesses? 1. It means CO, carbon dioxide, CO2. If it existed, CO3 would be called what? Carbon trioxide. All right? So sometimes there are prefixes in front of the first thing also. So you could have like tetracarbon dinitrogen, and it would be something like that. Okay, so prefixes, they can be on both atoms. All right, then right here in this box and this box, that will tell you the charge of metals and nonmetals. Now we already know those because we also put that right here. But there are some metals that we did not specifically give you the charge of, and I know this is blurry, but they're written right there. Aluminum, zinc, cadmium, and silver. They have their own specific charge. And then, we never told you the charge of the polyatomic, or not the polyatomic ions, the transition metals. If you don't know, you can't find them, then they will be given to you with a Roman numeral. And we'll see what that means in just a second. All right, so what do you think you use this side for? Maybe to find the name. That is not what we're going to do today. We're going to flip it to the back, and we're going to use that side to do what? Find the formula. So here we go. This is kind of hard to see up here, but it's kind of ugly too. Hold on, give me a second. Let me get rid of these. Okay, don't. Go that way then. These are shaded, and you don't have to shade these, but what this is its instructions. It's yes or no questions that we follow. Lizzie, if you just touch it once, nice and soft, it should work. Or if you go like that a million times, it will eventually work. All right. We follow these yes or no questions until we end in a box that gives you instructions. Okay? It's a naming schemata. It's just like plans you follow. But the ones that are in pink, those are representing how we write the formula for ionic compounds. The one in the blue, those are the ones that are representing nonpolar compounds. And the difference, and please add this, the difference is here. In this box and in this box, you drop and swap. So like I would add that right there, drop and swap. Drop and swap. But in the blue box, well, I'll take a pause. We're probably going to even run out of time before we even do anything. We'll do our best. Drop and swap. Remember that? We've got the numbers above, then we lowered them and switched their places. Does that seem familiar? Were you here for that? Okay. What does it say right here, though? Warning what? Do not balance the charges. So in this box, you do not drop and swap. No drop and swap. That's just ugly, but whatever. So now we kind of have this ready to go. Will you take your lab book and just look at the very, very back? And there's a crap ton of stuff to do on that page, right? We'll get through it. It's not hard. Once you figure this game out, some weirdies will actually enjoy it. All right. So here we go. I know mine's squeezed and a little bit fat, but we're going to do it. So if you look at number 76, everyone point to 76 so I know you're with me. We are going to find the formula of sulfurous acid by using our naming schemata. This naming schemata doesn't have a giant arrow that says start, but usually in English at least, you always start in the top right and work your way that way, right? Top left, thank you, whatever, top left. So we ask ourselves this question: is sulfurous acid the name of an element? No. If it said the word sulfur, it would be yes. But it says sulfurous acid, correct? So we go down. We just follow the arrows. Does sulfurous acid end with the word acid? Yes, it does. So we go over, and then it doesn't ask a question. It gives us direction. Write the formula of the acid by using the chart. What chart? The acid chart. Open the middle. The acid chart was on the far right-ish middle side. All right, and the name of the formula for that is H2SO3. That is sulfurous acid. That wasn't that hard, was it? That's like the U-turn on your driver's ed test. Like, I can do that all day long, just don't make me parallel park. Well, 77 is more like parallel parking than a U-turn. So here we go. 77 says iron something. What's the iron what? A 3? 2. All right, so there's Roman numeral 2, and then what? All right, thank you. Iron 3 hydroxide. Please stick with me. Is this the name of a single element? No. Does it end with acid? No, it ends with hydroxide. Are there metal and non-metal atoms? Yes. Look, if it starts with a metal, this is always a yes. So you could rewrite that. Is there a metal at the start? Yes. Does it end with any of those words? Yes, it does. So we go to this box, and now it tells me, write the symbols of the metal, then the polyatomic ion. Use tables and polyatomic charges to balance the plus and minus charges by using subscripts. That's a lot of words, but it means write the stuff and then drop and swap. So here we go. What is the symbol for iron? Fe. What's the symbol for hydroxide? OH. Where'd you find that? Bert. I know. Eat it. The rest of us that didn't have the best teacher ever born on the planet Earth, all right, the rest of us, look here. Hydroxide is a polyatomic ion on the left middle-ish. Everyone point to it. Right here somewhere. Does everyone see hydroxide? All right. So it is OH. And whenever you bring a polyatomic ion, bring its charge. So what is its charge? -1. This Roman numeral +2. FeOH2. Get out of my room. We'll teach you.